So let's proceed with our lecture today. Okay, never mind. So let's proceed with our lecture today. Okay, so we are already in week 12 today, 6th of September. We're in week 12. So here in this week 12 for our lecture, we will proceed with system design. Okay, system design chapter 11. Last week we already covered on system architecture. So today we will try to finish this one chapter, system design. Okay. So system design. So as you can see, we have 50 page here. However, in this chapter, it is more to like a concept. Okay, it's more to like a concept for this 50 pages. Okay, so for this chapter in system design, we will learn on the difference between analysis and design. What is analysis and what is design, and what is the difference between analysis and design. Okay, same with logical and physical design. We will see what is the logical and physical and what is or what are the difference between them. And then the difference between system and detail design, character of a good design, and the need to make trade-off in design. So these 5 points we will cover in this 50 slide. Okay, so so first we will go into the first one. Okay, how is design different from analysis? Okay, so before we go to see what is the difference between these, what is the difference between design and analysis, we need to see first, we need to know first what is design and what is analysis. So in order to know the difference, we need to know the definition or the concept first. So design is actually how the system will be constructed without actually building it. So design is how we want to design or how we want to develop. Okay, so design is on actually the plan, how we want to conduct or how we want to develop, how we want to design, how we want to develop or construct the system without actually building it. It's like a plan. Okay, so here as you can see, without actually building it. So design is like a plan only, a plan on how we want to construct or how we want to design them. Okay, so before we go on the second point, I think there's some like it's minor error actually. So here we go to the third point first. For design, design specifies how it will do it. It's referring to the system, application, or whatever we want to develop. So design specifies how we want to develop or how we want to construct our system. Okay, that is design. Second, here the term analysis. So I think most of you know already the concept of analysis, analyze. That means we want to identify, we want to analyze. Okay, so here in this context, in system, so we identify or we analyze what the system must do. Okay, what the system must do is referring to the function, requirement. Okay, for example, student intranet. Okay, student intranet. So the designer first, they will, of course they will design and then they will analyze what the system must do. Oh no, before they design, they analyze first what the system must do. That means they analyze what is the requirement or what is the function of the system application or any program that you want to system application or any program that we want to develop. Okay, so here there's two terms, analysis and design. Okay, design is how we want to design or construct. Analysis is what the system must do. Okay, so here after we already capture what is the concept or what is the definition of system design and analysis, now we will see what is the difference between these two terms, analysis and design. So here the analyst seeks to understand the organization, its requirements and its objective. So analyst here is referring to business analyst. Okay, business analyst. Like I already informed you, they are the people, or they are the person or group or team that will be like the middle person between the developer and the user. User, for example, you guys, student intranet, you are the user. Okay, so you are the user, and then this BA will be the like middle person. Okay, of course not from all of you. Of course there will be some, like I don't know how when they design the student intranet, but however, analyst, it can be business analyst, system analyst. Okay, those people, okay, will be the middle person. So they will try to understand the organization, its requirement, and its objective. Okay, organization, if for student intranet is referring to our TAR, you see, its requirement, the function of the student intranet, and the objective. Okay, what is the use or what is the function of our student intranet? Okay, these people will try to understand them. Okay, organization, requirement, and objective. So on the top, on out of these three, requirement is the most important thing. Okay, requirement is, of course, you know, functional and non-functional requirement. Okay, they will try to understand them. Okay, it is very crucial because they need to deliver whatever the user want to the development team, the programmer, the developer. Okay, so the designer seeks to specify a system that will fit the organization, provide requirements effectively, and assist to meet its objective. This one is like I mentioned just now. So these people, actually, here as you can see, we have analyst and designer. Actually, team, these two term, analyst and designer, are referring to different group. However, for usually analyst and designer are the same people, but these two things, they have different job scope. Analyst is the middle person, designer, this group will design the system. Okay, they will design and they will specify the system so that the system that they design will cover the requirement. Okay, however, it can be the same person, analyst and designer. Okay, so after the analyst already gather the information, the requirement, after they already understand them, they will specify a system that will fit the organization, provide its requirement. Actually, the same one with the first one. Okay, so effectively and assist it to meet its objective. Okay, and then now here we have a case study again. So how design different from analysis? Okay, what is the difference between these two terms? Okay, so here we have example case study. So analysis identifies the fact that the campaign class has a title attribute. So here analysis. So here analysis. So what is the definition of analysis just now? In page 3, analysis is what? Okay, what the system must do. Okay, so here they identify the fact that campaign class has a title attribute and design. Okay, how? The keyword here, how. Same with the previous slide. Determine how this will be entered into the system, display and screen, and stored in DB together with all the attribute, campaign, and other classes. Okay, analysis is identify what, okay, what the system must do, what they need. Okay, what they need for the system. Here, design is how. Okay, analysis what, design is how. Okay, and then when does analysis stop and design start? Okay, so here we have a waterfall life cycle. This one, I believe you guys should remember already, the phase in waterfall. What is the phase in waterfall that we have covered in our previous chapter, student? I think in our lecture we have around 7 or 8, but I remember I thought you guys you only need to remember 5. So can anyone tell me what is the 5 step in waterfall or 5 phase in waterfall? The most basic phase. Anyone? Ivan, what is Farah Vincent, Conjan Shak, Kelvin Shak, Rachel, Jeremiah? So what do you think? Phase in waterfall, the thing that I said, this is basic. At least try to remember 5 of them. In our lecture note, I think 7 or 8. I don't remember, but I mentioned 5 only. So what? Noel, Ian, Nathan. Actually, there are 5, which is planning, analysis, design, requirement gathering. Requirement gathering. Oh, okay. The 5 thing actually for waterfall, remember, is this thing. PLANNING. Planning, analysis, DESIGN, design. Number 4, implementation. Number 5, the last one, usually, how to spell maintenance. Number 5, I'm not sure on the spelling, maintenance. So planning, analysis, design, implementation. Oh, my book. Planning, analysis. Planning, analysis, design, implementation, and maintenance. This one is too basic. Okay, so if you cannot remember in our lecture note, I think 7 or 8, I don't remember. But this one is the basic one in Waterfall. So try to remember. PADIM, planning, analysis, design, implementation, and maintenance. Okay, try to remember them. Okay, so that one is in a waterfall life cycle. So in case you guys forgot what is a waterfall life cycle, it is actually a SDLC, System Development Life Cycle. Okay, SDLC, System Development Life Cycle. So this one, waterfall, is the traditional one or the basic one out of other cycle, of other approach. Okay, so in waterfall life cycle, there is a clear transition between the two activities. Okay, why it is that here? It is a clear transition between the two activities. Okay, again, like I already explained in our previous chapter, waterfall, we do not, it's not we, they do not allow like iteration. That's mean up to one phase. For example, after one phase, they go to another phase. They cannot go back to the previous phase. For example, like I mentioned, we have planning, analysis, and design. Okay, for example, in design for waterfall, for waterfall, we cannot go back to the analysis. If you already in design, the third phase, we cannot go back to the second phase. That is the concept of waterfall. It's one way, cannot iterate, cannot go back. Okay, so of course, there's clear transition between two activities. Okay, and then in iterative life cycle, the analysis of a particular part of the system will precede its design, but analysis may be designed in parallel. Okay, iterative life cycle. Okay, iterative, that means we allow iteration, we allow to go back to the previous phase if there is any change. Okay, so it is important to differentiate the two activities and the associate mindset. So we need to know what before we decide how. So here on the fourth point here, or on the last point here, in other words here, which one comes first? So analysis, what should come before, can I write something? Hmm, analysis is what? What? Hmm, before design. EES. Oh, okay. Here is actually for the fourth point. So what is referring to analysis? Analysis, what the system need to do before the design, how we want to do it. Okay, I think this one, I won't say. Okay, of course, before we design, we need to know what we want to develop, what we want to construct. Okay, we need to know first what. If not, how can we design if we do not know what we want to design? Okay, so we need to know what uh before we know how, or before we analyze how. Okay, analysis is what, before design how. So what before how, or analysis, analyze before we design. Okay, here we have traditional design. So making a clear transition from analysis to design. Okay, analysis here, analysis to design, analysis before design. Okay, making a clear transition from analysis to design has advantage. So transition is actually a change of state from analysis to design. Okay, we want to change the state of phase actually. In this context, it's a phase. Okay, so making a clear, we have this advantage. So project management, okay. Project management is there the right balance of activities. Activities is referring to here in this context analysis and design, okay. Activities if we're referring to this waterfall just now, this is the activities planning, analysis, design, implementation, maintenance. Okay, we need to check is there the right balance of activities. However, if you go to work, you will see the bias. Here will take time on design. Sorry, on design. Design here will take time to design will take time to develop. This one is on programming, okay, including the testing. Okay, is there the right balance of activities? And then staff skill. This is referring to the group or the member of our group. Analysis and design may be carried out by different staff. Okay, may be carried out. Sometimes we have the same people, same group, or sometimes it can be carried out by different group of people, different team. But usually they are the same people. Okay, to reduce the cost actually. And then client decision. Client decision is referring to our user. So client here, for example, your staff, student intranet, the client decision, of course, the user is the student, but the client here is referring to TAR, our college. So the client may want a specification of what before approving spending on a design. Again, they need to check what first. What is referring on the analysis? What the system must do before they approve the design. Design, for example, can be the UI, UI, user interface. Okay, so they need to approve first, approve. Okay, and then choice of development environment. Okay, development environment here may be delayed until the analysis is complete. However, for a perfect, no, I won't say perfect, there's no such thing like perfect system. I mean, for a system, usually here may be delayed until the analysis is complete. Usually they will, usually I repeat, usually people will analyze the environment in the analysis so that they know if what their design is compatible with the environment. Environment here is referring to where mm, how we want to develop them and development environment where we want to develop or where we want to deploy. Okay, here design in the iterative life cycle. Traditional is referring to the waterfall. Iterative life cycle is the one I mentioned just now, where we allow our phase from another phase, we allow them to go back to check back. It's not check, to go back from our previous life cycle. So this is the advantage of iterative life cycle. Okay, risk mitigation, making it possible to identify risk earlier and to take action. Okay, risk mitigation here is something like risk management. Okay, risk management. Of course, when we're designing a system software, let's take it as a system. Of course, there is a risk that we need to take into the account, that we need take it as a concern. So here is risk management, making it possible to identify risk earlier and to take action to prevent. Okay, for some cases, for some system, for a crucial or critical system, for example, for banking system, we know there is a risk. Okay, we all know, the team, those people already aware there is a risk on security. However, this security issue, this security concern cannot be removed. Like, we already secured everything, so we remove the security issue from our risk. That is almost impossible for banking. However, of course, there is a step or action that we can take to reduce the risk. Okay, that one is under risk management. And then change management. Okay, change the requirements are expected and properly managed. Okay, this one is in iterative. For example, iterative, like I mentioned, we have this one we allow to go back to the previous phase. For example, now we are already in design on the third level already. Design on the third phase. So for example, in the process you guys as a programmer, you are writing your code, and then suddenly your client, for example, uh yeah, I don't want, it's okay. For example, any client try to change the requirement, so we can go back to our previous phase or level. So expected and properly managed, because we allow this phase to go back to the previous phase. Okay, team learning. All the team can be involved from the start of the project. Okay, that means everyone from planning, analysis, design, implementation, maintenance, they can involve. They are aware. They know what is the current state, what is the current process, not process, current state. Okay, improve quality. Testing began early and is not as a big bang with no time. Okay, here testing. Testing is very crucial. Like I said, developer, me as the developer, even though before I send to tester, I already test on my local, on my environment. I said, okay, this one is already fulfill the requirement. However, I remember I mentioned to you guys, I said, we as a developer, we cannot pass our own program. We need to pass to the tester or quality check. So those people will decide if whatever you develop is pass or fail during the testing. Okay. Pass or fail. I think you know that in testing. So begins early and is not done. So testing begins, that means they are aware each of the phase. That means from one module to one module. Okay, not as a big bang with no time. It's not that suddenly they give you the whole system to test, because test sometimes take time. It's not sometimes, yes, test takes time. So we cannot deliver our whole project at a time to a tester. Okay, and then here, seamlessness. The same model, the class model, is used through the life of the project. Okay. Here we cannot use, oh, it's not that we cannot. The same model or our class model is used through a, okay, is used through the life of the project. And then during the design, additional detail is added to the analysis class, and extra class are added provided the supporting functionality to user interface and data management. Okay, here if we, in case we have something that we want to add to help the function, to help the function, for example, the UI, to help the user experience for UI UX. I'm not sure if you heard that, but I take common, UX the user experience. So in case we want to add something to help the user experience, so we can do this in this phase. Other diagrams are also elaborated in design activities. Other diagrams can referring, for example, like what you already did in your assignment, use case diagram, or few more diagram, okay, in your assignment. If you do your assignment, then you know, okay. Okay, so before we move to logical and physical design, is there any question on design and analysis? Can I proceed to physical and logical design? Okay. So next we move just now our analysis and design. So actually, if for analysis and design, what's important is you know the concept. If you know the concept, what is analysis, what is design? Analysis is on what the system must do. Design is how the system should perform. Then you guys should be okay already. That's one, like I said, it's only a concept. Okay. So next is logical and physical design. Okay. Logical and physical. This one, I think you heard a few times already when I said this one is not in your tutorial. Okay, logic flow. If you remember in your practice tutorial, we have the term logic flow of the system. So here we will see what is logical and physical design. Okay, in structured analysis and design, a distinction has been made between logical and physical design. So here on the second and the third point, they already explained. Logical design is independent of the implementation language and platform, while physical design is based on the actual implementation platform and the language that will be used. Okay, so actually logical is actually more on the conceptual and abstract. Okay, conceptual and abstract. And then physical is actually the actual, the term here, actual input or output process of the system. Okay, actual input or output. Logical is usually based on, it's more abstract and conceptual. Okay, uh, logical. Okay, it's not later. When you go to work, when it's not when you go to work, when you already work later. So if people ask you what is the logical design is usually referring to the flow of your system. Okay, so you will hear a lot of people will say the logic of the system is this, and this. Okay, that means logic of the system is referring to the flow of the system. For example, student intranet. Okay, the logic of the flow is first the user. I'm not sure student, but for staff, we have staff intranet. So the logic of the system is first we need to do the authentication process, where we need to key in our pass user staff ID and username. Okay, so and then after we already log into the system, we can do this, and do this. Okay, so for example, if you want to update the attendance of the student, I need to go to attendance, and then I need to click on the calendar, and then subject, and I click on the name. So that is the process of attendance. So that is the logic. Okay, so logic is usually abstract and conceptual, how or what is the flow, and physical is the actual input of IO, input or output of the process of the system. So here logical and physical design example. Okay, some design of the UI classes can be done without knowing whether it is to be implemented in Java. Okay, this one, okay, Java, CPP, or some other language type of field, position, and Windows. This is correct. Why of course this is correct. I mean, yeah, this is the statement here, because when we design, I believe you study HCI. When we design our UI, it can be done actually without we know what language we want to use. Okay, how we want to implement this code, or how we want to implement this interface UI. Okay, we just design without concerning or without knowing whether we want to implement in Java, CPP, or some other language. Okay, for example, now if I ask you to design a interface for a student management system, you can design without knowing how you want to implement it. Okay, some design can only be done when the language has been decided. The actual classes for the type of field the layout managers available to handle without layout. This one is actually when we already do the, remember I said about low fidelity and high fidelity. Okay, this one is already on high fidelity, or the high fidelity is referring to the interface that is the closest to the real interface that we want to design. Okay, for some low fidelity, we just design some UI without plan how we want to implement. But some, for like I said, high fidelity, so there's a concern already how we want to implement. Yeah, how we want to implement. It's not implement, how we want to design actually the system. Okay, so here logical and physical design. It is not necessary to separate into two separate activities. Activities referring to logic and physical design. Okay, so it may be useful if the software is to be implemented on different platform. Platform is referring to how we want to design. Then it will be advantage to have a platform independent design that can be tailored to each platform. That's mean for these two, if they have different platform, it is the best if we have independent design. Okay, independent. That means they do not depend on each other, but still they can adapt. Okay, they can it's not adapt. They can work with each other. Okay, tailored to each platform. That means from logical and design, they should be independent. They shouldn't be. They should be independent, and it is the best also if they can tailor to each platform, to each other. Okay, that one is on physical and design. Physical and logical design. Yeah, physical and logical design. Next, we have this MDA. This MDA already mentioned, I think, on last lecture, but I remember this part. Okay, MDA, model driven architecture. So it is actually approach software design. It is an approach for software design to develop and implement. Okay, MDA. So here or oh, here also we have few terms or few abbreviation, PSM and PIM. Okay, PSM, platform specific model, and PIM, platform independent model. Okay, so here if you forgot, you can go back to our previous chapter. And the idea of MDA is to separate the business and application logic of a system from underlying platform technology. Here is actually like a concept only. So you need to know what is MDA. This PIM and PSM, I remember I mentioned these two, they always bind together. And this word is packed under MDA approach. So PIM with platform architecture is equal to PSM that can build and execute on a particular platform. That means this one, PSM, platform specific model, is the combination from PIM with architecture, okay, to produce the MDA. So here, PSM, platform specific model, a single PIM could be implemented in different ways. For example, J2EE. This one is Java 2 Enterprise Edition, .NET and Corba. This three is this one J2EE. It's actually an application .NET. I'm not sure. This one is it's not. I'm not sure. This one is programming language .NET and Corba. It is an Corba is actually stand for Common Object Frequent Broken Architecture. Okay, this one is an approach to. So here is the example of how we can implement PIM to produce PSM. So PIM can be used to re-implement the functionality of system on different platform. Okay, that one is PIM and PSM. So, wait, 1 minute. And then we move to here, this page, system design and detail design. Okay, on the new subtopic here. System design and detail design. So system design deal with the high level architecture of the system. Okay, architecture, the term here we already covered in, I think, the last two chapters, system architecture and software architecture, if I'm not mistaken. So here, structure of subsystem. Okay, so system design need to deal with the structure of subsystem. Like I said, when we want to develop, usually the normal practice when we want to design a system, for example, student intranet, we need to break them into module. Module here can be referred as a subsystem. So this process, or what we call as modularization, breaking our system into subsystem. So we need to concern on this. We need to see the architecture of subsystem. And then distribution of subsystem on processor. Okay, communication between the subsystem using what? Uh, Okay, communication between subsystem, how the subsystem want to communicate, using what, or what is the message that they want to pass. Okay, standard for screen report, help, etc. This one is on the one thing. Let me think first. Consistency. Okay, standard. Okay, standard for screen report, help, etc. That means this is the consistency. And then job design for the people who will use the system, the target audience, the target user of our system. And then here, object-oriented detail design, add details into the analysis model. Okay, we add this detail during this part, analysis model. So type of attribute, operation. Attribute is the letter in this chapter. If you forgot what is attribute, but I believe you know what is attribute in our class, the class attribute and process. This one should be on the second part. I'll show again later in this lecture. So the type of attribute, what should be included as the attribute to our class. Operation signature. Okay, operation is the function in our class diagram, assigning responsibility as an operation, additional class to handle UI, additional class to handle data, design of reusable components, and assigning class to package. Type of attribute, like I mentioned, what should be included as a type of attribute. Operation is the function, responsibility as operation. This one also operation, additional class to handle UI. What needed to have our UI, and data management, reusable components, the components that we can use for other module, and assigning class to package. So package is already, I think you know too. Package is like a group where we want to where we want to so it's like a grouping. So assigning class into package where we want to uh, where we want to group our class into a package. So usually class, if you want to group them, they have something in common, usually their attribute, so that they can group or package into a group. Yeah. And then quality of analysis. This is crucial to, after we have our analysis, we need to do this part, qualities of analysis, check the quality. So usually we have a process, or usually a group of, we call them as quality check. So they will check on the, even from the analysis or development part of our system. So quality of analysis, correct scope. So scope is very general. Okay, scope is very general, not only to the functional requirement or what is the purpose of our system. They need to check everything into the, including the environment of our system where we want to deploy them. Okay, so everything in the system is required. They need to check correct scope, completeness. Okay, from the term here, you know, you can guess already, complete. Everything required is in the system and everything is documented in the models. Okay, this one is after everything already done. Okay, one actually for a project, not only on the not only on the product, not only on our system, not only on our application. Okay, uh when we already finish this part, okay, we need to do the documentation. Okay, documentation including all the diagram that we use in our project. So completeness, not only on the product but also in the diagram. Whatever diagram that you include, you need to documented them. Okay, so this part is usually for a programmer. I won't say that we had, but you know, sometimes, usually programmer, they are boys, so sometimes I'm not one of them. Sometimes they don't really like to do this part where they need to document, they need to write. They are okay with coding, but they are not okay with documentation. Okay, you need to document them everything. including your code sometimes, but no, we won't give code to our client. We just give them like screenshot, diagram, what we need. Okay, correct content. Okay, accurate description of requirement. This one too will be checked by, I said this now, quality check or tester. So correct content. We can develop a full working system. But is it whatever we deliver? Is it the accurate description from our requirement? So we need to check this back. Okay. And then consistency. This one, consistency. Each element is consistently referred by the same name. Okay. For example, if we design a interface where we want to go back, for example, I will design a interface where I have this function where I can go back to the previous page. Okay. The simple one I can think is on the button, so that to let the user, if you click this button, you can go back to the previous one. Consistency here is referring here by the same name. For example, on the button just now, if you want to use back, then you keep that button, the term back there in all your system. Or if you want to use previous, you keep that term. Don't use different, or don't use here in this page you use back, and then on the next, on other module or another page you use previous. Okay, that is not consistent. You need to fix, you need to have a fixed name, or fixed name. That one we call as consistency. Even in programming too, but this one is OOAD. But even in programming too, if you go to work as a programmer, they have like a practice. Actually, it's not practice, it's like consistency when we're writing a code. Okay, for example, if you want to do this, you need to do this, even though you have different approach, but they have this consistency to make it easier uh in coding. But here in OOAD, that I mentioned, by the same name is referring to the button. If you want to use back, then you use back. If you want to use previous, you can use previous. Okay, here we have qualities of design. So far, any question? Okay, now I proceed. Okay, here as you can see, I think here is 12 element. You calculate, you count one. Okay, here I get design. So we have functional, efficient, economical, reliable, secure, flexible, general, buildable, manageable, maintainable, usable, reusable. Okay, we have these 12 element, this 12 quality, which we will look here. Okay, so this is the quality of our design. Okay, if we check this one, if you check from this slide, it's look like easier, but when we actually practice, when we go actually practice this thing, this element, then it is not as easy as what we study here in class. So the first one, functional. Okay, functional. So functional, like I mentioned, we have two, which is functional requirement and non-functional requirement. Okay, this one you should know to what is functional requirements. But usually when we're designing a software, there is a bias. Usually we will only look at the functional of the system. Functional of the system is referring to what what the system need to do. As you can see here in our slide here, system will perform the function that it is required. Okay, in our there's one document actually, but this one is on BA side. I don't really remember what is the document. There's one specific document that will tell everything. I forgot because I never involved in BA stuff. So there's one document. So in that document, they will specify actually what this system need to do. Okay. It is in very detailed manner. That's mean from this system, they go to this module. Then this module have this, I forgot the name already. But for example, in this module, you have these 5 buttons. So in these 5 buttons, they have actually specified what they need to perform into such a detailed function. Okay, system will perform the function that it is required to. Okay, so like I mentioned just now, even we can deliver to a client one working system, but sometimes they will reject our system. Why? Because it is not what they want. Okay, even on a small matter, they will go back or refer back to, or they will return back to us. Okay, functional, efficient. The system perform those function efficiently in terms of time and resources. Okay, if after we already it's not after, usually in the analysis phase, of course, we need to know what is the function. But even though we already identify, or even though we already know what is the function, but we need to have this concern too. How efficient is our system? Okay, how efficient is the student intranet system? Okay, efficient, how efficient they work, and economical. Okay, running cost of system will not be unnecessarily high. This one is okay, here in this lecture, of course, for education, we said running cost of system will not be unnecessarily high. But no, if you go to work, then you know. Yeah, running cost of a system will not unnecessarily high. Let me give you guys example. Okay, so like you already know, I was a programmer and a tester in my previous experience. Okay, so we already developed this one system, AML, like I already mentioned, crime financial, to combat with them. So for example, if in our system here, they want to change, for example, the button just now I said back or previous. If they said they want to change that system, or it's not the system, they want to change the name of the button, it can cost them sometimes. I didn't know this too because I was a programmer. I never really involved in cost or anything of the system, but I like, I saw my manager, he like accidentally show me the document. So I know from that one button, it can cost up to, I saw there's one enhancement, small enhancement. I know that enhancement, but it costs around like thousand. It's not, oh my God, it's cost around like 100,000. Yeah. 100,000 of ringgit. Okay, so here of course, in like, that's why I said our what we study is can be different. So economical, running cost of a system will not be unnecessarily high. Sometimes when we already deliver to them and they request us to change this button, for some very, not all, some client, so to change that button, it will cost 100,000 of ringgit Malaysia. Okay, but for simple, or but maybe because I'm from banking, so maybe for some system for student intranet, I'm not sure what is the cost of the system, but yeah, some costs or some system will be not unnecessarily high. Okay, and then reliable, not prone to hardware or software failure, will deliver the functionality when the users want it. Reliable, this one is another crucial element that we need to check on. Okay, for example, we have some failure can be anything, it can be from our software or our hardware. For example, hardware is server, our physical server. What if we deploy, what if we store or save our deploy, yeah, what if we save them in that server, then some, since it is a physical server, of course, there is a risk to fail. So what will happen to our system if the hardware is fail? Okay, we need to think on this one. Or can our system working as usual? Or what is the plan if there is such thing? Okay, this one is on reliable, and then secure. The issue, I think almost every system we have this concern, but the difference is how severe or how serious is the issue. But security, of course, there will be security. Okay, protected against error, attack, loss of valuable data. Okay, protected, usually it is for security, for security concern, it will we will focus on the protecting our data from an attack and loss of valuable data. Okay, and flexible, capable of being adapted to the new use, to run in different countries or to remove to a different platform. Okay, flexible. Our system need to be flexible. Okay, for this one, let me give you an example. Banking again. That's all I have, banking. So flexible. So for example, we have this our system. We call it as AML. Okay. So we have, of course, we have client here in Malaysia, few banking, local bank in Malaysia. So we need to design a system that it is flexible, because we have client from Hong Kong, Vietnam, Cambodia. Hong Kong, Vietnam, Cambodia. I'm not sure China is the same with Hong Kong, but yeah, those people. So we need to design a system that will be flexible not only to our industry here, but as well to other country as well. Okay, general purpose and portable mainly applies to utility program. Okay, the general purpose. And then buildable. Buildable, there's one word which is doable. Design is not too complex for the developers to implement it. This one is buildable, or in the industry we call it as doable. Okay, so for BA, usually BA they do not know how the developer, how the developer is going to develop them. So there's is like a conflict here. Okay, conflict between programmer and BA, because uh buildable or doable, because um, of course everything they will say, the BA will say, yes, we can do this, we can do this, we can do that. Okay, because it's about the cost of the system. Okay, so of course our BA will say yes, but when it come to us, then we have a few concerns. Okay, actually, yeah, sometimes what the BA said they cannot do, but for us, when it come to us, we have so many things that we need to take as concern. Doable. Design is not too complex for the developers to be implemented. Sometimes BA, they just say yes. At the end of the day, we as a developer, we need to think. And then manageable, easy to estimate work involved and to check of progress. Okay, manageable, the term here, manageable, easy to estimate the work involved, what's involved, and to check of progress. And then maintainable. Okay, design make it's possible for the maintenance programmer to understand the designer intention. Maintainable, if we check back on the phase, just now maintain is on the last phase. That's mean we already implement. Okay, we want to maintain. It's already on go live. It's already on the production server, it's already go live. So what if what if error or any bug? So we need to make it easier to maintain. Okay, for example, if you want to maintain this module, it shouldn't be interfere with other module. And then usable, provide user with satisfying experience, not a source of dissatisfaction. Okay, usable, provide user. User is referring to us, the student or the staff, with a satisfying experience. Experience here is referring to the UX, user experience. Okay, UI, UX. And reusable. Elements of the system can be reused in other systems. So that's mean when we want to develop a system, if we already have that function or element, in programming, we call it as a function. So we can only call back the function. We doesn't need to write a new one. So element, we can use back the element. That one is on reusable. Okay. Any question on the quality of a design? Next is criteria for good design, cohesion. We have 20. Can we have 5-minute break? Can we have 5-minute break until 10, 11, 5? Yeah. Okay, thank you. Hi guys, so let's continue back our lecture. So just now we stop at this one, quality of design. So we'll proceed with this one, criteria for good design, cohesion. So cohesion here is, before we go into this slide here, cohesion is actually referring to the action to unite it, to form something as a whole, as a one part. Okay, so here cohesion is a measure of the degree in which an element contribute to a single purpose, level of element, or level of the contribution of an element to a single purpose. Okay, so the concept of coupling and cohesion are not mutually exclusive but actually support each other. So coupling, I don't remember which chapter, but coupling and cohesion. So they actually are supporting each other. So these people suggested several ways in which coupling and cohesion can be applied within an object-oriented approach. So we have maximize and minimize. Yeah, correct. Maximize and minimize later. So maximize cohesion is actually a module that we produce to perform a clearly defined process or a group of process that are functionally related to one another. Okay, so this one is maximize cohesion, a group of process that are functionally related to one another. And there's one more term, minimize. So coupling describe the degree, again the degree, the level of interconnectedness between design components. So it is reflected by the number of links an object has and by the degree of interaction the object has with other object. The relationship or the association. Yeah. And then next we have minimize coupling. So produce module that are independent of one module. Okay, here maximize. So a group process that are functionally related, okay, functionally related to one another. While for minimize coupling, it is a module that is independent of one module that are independent of one module. Okay, and then we see the example of pure types of cohesion. Okay, cohesion, like I said, it is a process or an action. We form something or we want to unite something as a one part or one product. So coincidental cohesion, logical and temporal and sequential cohesion. Okay, so coincidental, it is a process where we group them without no obvious reason. Okay, no obvious reason to perform, no obvious reason, of course. We do not know. It's not that we do not know, but it is grouped but for no obvious reason. And then logical cohesion. Okay, logically similar process that are handled together such as input. Okay, logical similar process. And then temporal cohesion, process that happen at the same time. And last is sequential cohesion. Okay, this one is more to like sequential is a process. The output of one process being used input by the next. That means they have sequence from one process. It can be used as the input for the next process. Yeah, sequence. And this one we have a review question. So discuss the cohesion coupling from the poorest level to the strongest level. For cohesion and coupling, for this lecture, for this slide, actually we can only mostly on the cohesion from the previous part. But for coupling, you can refer back to our previous lecture note. I remember there's one term on coupling. Okay. So this is a review question on cohesion and coupling. And then interaction coupling. Okay. So a measure of the, again, like I said, interaction, a measure of the number of message type and object sends to other object and the number of parameter passed within the message type. So why they want to pass message? I asked you guys last time already how object interact with each other is using a message passing. So they pass a message that contain it can be a instruction, it can be a request, or it can be anything between the object. Okay, message passing using a message between the object or class. Okay, so should be kept a minimum to reduce the possibility of change replaying through the interface and to make reuse easier. Okay, here is for interaction coupling. So here is the example actually for pure, poor. Is it poor? No, not yet. Yeah, poor inheritance. So here inheritance coupling. So inheritance coupling describe the degree where we can measure to which a subclass actually needs the feature it inherits from its base class. So if you guys remember, inheritance is actually a process where we where we allow a new class to be created from a existing class. Okay, here is per inheritance coupling. So here, this one is the part I said just now, attribute and method. Class is vehicle, vehicle is class, description, service that, maximum attitude, type of speed. This one is on attribute and this one is on method. Okay, so pure inheritance coupling, unwanted attribute. So this one is attribute. So look at max altitude and takeoff speed. These two is unwanted attribute and operation is check altitude and takeoff are inherited. Okay, so if you don't understand this part, so let's move to the next one. Okay, here why they said here is pure coupling. In page 27 they mentioned this as pure coupling, poor inheritance coupling, because we can improve this by actually using this one. Okay, so if you go back on page 27, why is it poor? As you can see, we have land vehicle. Land vehicle, we doesn't need the maximum altitude and takeoff speed. Okay, maximum altitude and takeoff speed. Usually this one is for airplane. So here we have land vehicle. So we doesn't need this attribute. That's why it is mentioned as unwanted attribute. However, we can improve this coupling by this one. We have vehicle, vehicle, land, and air vehicle. So the attribute just now where they mentioned in the previous slide as unwanted, here we can actually use as a air vehicle, airplane. So we have maximum and takeoff speed and check altitudes and takeoff. This one for air vehicle because this land vehicle doesn't need this attribute. That's why it's mentioned as unwanted. It's not poor, what is it? Poor inheritance or unwanted attribute just now. Okay, so now we can improve by giving or creating a new class air vehicle where we give them this attribute and give them this function. And then next, here we have operation and class cohesion. So lecturer as our class attribute and our method or our function is to calculate room space. Okay, good operation cohesion but poor class cohesion. Okay, this is the example where it is a good operation but it is a poor class cohesion. But next we have an example. So here poor specialization cohesion. Okay, so specialization cohesion address the semantic cohesion of inheritance hierarchies. Yeah. So here, wait, cohesion, like I mentioned, it's like we try to form or we want to group as a one part together. So cohesion here in this attribute, it is referring to the, it's not the level, but it's more to like this attribute, how much, it's not how much, it's like referring to which element inside this module is belong together. It's not uh, it's not the level. Is it it's not is it, it's like how suitable they are to be together. Yeah, how suitable. Yeah, so how suitable they are to be together as a group. So here number, strict town, security, and pseudocode. So here is the best, it's not the best, yeah, the best class And from this base class, we can separate them by this other class, which is person and company. So this one is a hierarchy. Yeah, it's a hierarchy of this example. So address, person, and company. Okay. So this is per specialization cohesion. Okay. But why is it set per? Because, okay, from this one, we know that this is the class address, person, and company. But, okay, for this one, we know that person can have address and company can have this address too. But this one is an easy example, easy term that we use. What if in our system, because in our system, sometimes we use the term that we are not familiar. So from this hierarchy, we can improve with this one in the next one. Okay, we can improve by this one. In the previous patch, we do not have this one and this one. So it can be improved by using the address class. Address class is referring to this one. So we know that this class is related to this class by referring this person is live at this address. Okay, we can improve by using address class. So like I said, for this example, we know that person live this address, company have this address. But we do not know in some other in our diagram for the term that we are not familiar, so we don't know what is the association. For example, here is A, here is B, and here is C. No, here is A, address is A, person is B, company is C. So we do not know what is the relationship between B and A or C and A if we do not have this address class. So this address class is very helpful. Okay, especially for the complex diagram. Specialization, cohesion. Okay, so here is the difference between coupling and cohesion. Any question? So here we have so here is the difference between coupling and cohesion. So even though coupling and cohesion deal with the quality of a module in software engineering, they are entirely different concepts. Okay, so like I said, cohesion is something here in this chapter that we learn. Coupling is a concept that we already learned previously in previous chapter. So there are two different concepts. Okay, so here cohesion focus on how much the functionality are related to each other within one module. Okay, coupling deals with how much one module is dependent on other program module within the whole application. So coupling is one whole application. Okay. Wait, these two is in one whole application, but the difference is how much the functionality related to each other. But for coupling, it is how much the module is dependent. Okay, referring to the functionality and functionality, how much it is related to other functional in one module. And for coupling, it is how much one module is dependent on other within the whole application. Okay, so in order to have the best quality software, cohesion and coupling should be reached the two opposite end of their spectrum. That means it is mentioned up there in the first point. It is two different concepts, but that's why they should go to they have their own function actually. So in other words, loose coupling and strong cohesion provides the best software. Having private fields, having private fields, non-public class, and private method provide loose coupling while making all members visible within the class, and having package as the default visibility provide the high cohesion. Advantage of coupling and cohesion: two principles help the software to be reusable and easy to maintain. They only state here one obvious advantage for coupling and cohesion. Okay, reusable and easy to maintain. So this one again reviewed question, discuss the different what is cohesion and coupling. And next we have this new Liskov substitution principle or LSP. Okay, so what is LSP? This is an approach actually. So defined by this person, so known as the scope substitution principle or known as LSP. So LSP, this one, the concept, when you heard this one, LSP, what you should know, substitution. Okay, substitution. That's mean we derive. In this concept, the concept of LSP is mostly like derive. Derive is before we go to this one, let me explain to you derive. Derive is a term that we use to produce something new from what we already have. For example, mathematical equation of any physics formula. So from one formula, we come out with another formula. That's what we call as derive. Or here in this context, LSP or derive. So this concept, this principle is using derivation as a concept. So it should be possible to treat a derived object as if it were a base object. So what is a derived object and what is a base object? So base object here is referring to the original object. Mm, yeah, the original object. Derived object is an object that we produce or that come from this original object. So that one is derived object and base object. Original object that derived object is an object that we get from base object, original object. So we need to, it should be possible to treat this derived object as if it were a original object. Okay. So the two term only, derived object and base object. So essentially the principle state that the object interaction should be possible to treat a derived object as if it were a base object without integrity problem. So the second point here explain that the interaction, the message passing, so it should be possible that this derived object should be treated as a original object or a base object. Okay, there should be no like mm, integrity problem. Integrity problem here in this context is referring to, we know that it is a derived object, so that we should, or the method should go to them equally, like we treat them equally. Derived object should be treated equally with base object. Okay, and if the principle is not applied, then it may be possible to violate the integrity of derived object. This one in easy word, I can say it's like equality in treatment. Yeah, I'm not sure if that's the right term to address this here, integrity. So integrity is actually the quality of being honest and having a strong principle. So these two objects should be treated equally. Yeah, should be treated equally. Okay. So here is the example of list of LSP derivation. Okay, so here we have two class, check account and mortgage account restriction to satisfy LSP. So like I said, LSP is the derived or derivation. We derive object from original object. So here, this mortgage account and check account, we have this account name. We substitute or we derive this part. Okay, this inheritance of debits mean that the hierarchy is not list of compliant. Okay, so here is restructuring, or what is the principle of LSP. So measurable objective in design. Oh, by the way, that is LSP. So like I said, LSP, yeah, that is the only part for LSP. So what you need to know in LSP, if you don't understand, LSP, if you go back to scroll in the previous slide, LSP referring to derivation. That's mean from one base object, we derive another, what's the term already? Derive object. Base object, original object, we come out to produce a derived object. Okay, that's the only term, that's the only concept for LSP. Next, we have measurable objective in design. Okay, So before I proceed, is there any question? Is there any question to ask? Mhm. Can I proceed? Yes, I should proceed. No question. So here, measurable objective in design. So from the term here, measurable objective. Objective referring to our requirement. Objective of the function. Requirement of the function. Huh? I mean objective of the system. Function of the system. Or yeah, in the design. So in chapter 6, non-functional requirements were described. So I think non-functional requirements you should know already even from your assignment part 1. I remember non-functional. Oh no, in your assignment, no non-functional requirements. But in your previous chapter, I don't remember 1 or 2, we mentioned about non-functional terms already. So in chapter 6, non-functional requirements were described. So how can we tell or how can we measure if this already achieved? So, measurable objectives set clear targets for designer. Okay, it is very important, especially to those group designer, BA, to have a objective that they can measure. Okay, and then objective should be quantified so they can be tested. It's not necessarily quantified because some requirements actually they are quite, I won't say different, but some requirements sometimes is not, but this is very rare. Some objectives sometimes they are not quantified. But however, we still need to test them. But let's take on the common one. Objective should be quantified so that they can be tested. Okay. Measurable objective in design to reduce invoice error by 1/3 within a year. So if you don't understand, this one is actually a situation or event example. So here, to reduce invoice error by 1/3 within a year. So for example, if we have this system, so we want to reduce invoice error. So how should we design for this? How can we tackle this problem? Okay, so here, to reduce invoice error, how can we design a system or how can we tackle this concern is first sense check on quantities, comparing invoice within previous one for the same customer, better feedback to the user about the items ordered. So this one is the design that we can take. uh yeah, it's a design on how we can solve this issue actually. So we can check for the quantities of our item. Yeah, I'm not sure. Maybe it's an invoice for our item. So let's say this is an item. So we should check on the quantities, and then we compare invoice within previous one with the same customer. This one is actually a method or approach how to reduce another method. So we compare invoice with previous one for the same customer. So for one customer, we check this year and last year or previous year invoice and better feedback to the user about the items order. Okay, this one is actually on the event or problem for this one. Okay, measurable objective in design to process 50% more orders at peak period. So this one is another event, another example to process 50% to process 50% more orders at peak period during busy period. Okay, so how could we design for this? How could we design for this? So this one is more to actually this thing usually this thing will only concern for the only BA will think this one analyst. So for example, if our client or our customer give us this situation, for example, to process 50% more orders at a peak periods, so our BA need to think actually how can design BA or analyst or our designer will think for this part actually. So how can they solve this? It's not an issue. How can they achieve this objective? So first, they need to think what is the issue, what is the objective. So the objective is this one to process this think. So they need to think what is how they can achieve. So design for as many fields as possible to be filled with default. Design for rapid response from the DB. Design system to handle larger number of simultaneous users. Okay, this one is only example, same with the previous example just now. Okay, so of course it is need to be measured. But like I said, like I mentioned, like just now, some of the objective is not measurable. For some simple, some simple system, we can get this one. Okay, we can get measurable objective. For what if it is a complex system, for example, obviously again for banking system, so not everything is measurable. But let's stick for this level. Let's stick with this one. This one, let's stick with this one. Objective should be quantified so that they can be tested. But the practice is different. The knowledge is here. Okay. So, okay. This one, planning for design. Okay, planning for design. Planning for when platform is known. Platform is, we know already how we want to develop or how or where we want to develop. Okay, and then we need to set standard here is very general. Okay, standard here is very general. It can referring to the designing team, it can be referring to the developer team. Okay, for example, when we want to design a system, let's say a module, let's say we want to design a module, so we have this diagram. Of course, we need to have a diagram. So we set a standard so that all the diagrams should follow these rules. It's actually like a rules. So for programmer, maybe they will use this. For programmer team, maybe they have, of course, they have standard when writing the code. When writing the code, okay, setting standard. So it's easier for them to develop or to design. Design first before develop. Okay. So allowing time for training. Agreeing objective and planning test, agrees procedure. So allowing time for training. Okay, we have time before we design them. Okay, agreeing objective and planning test. Agreeing objective is the mutual, I won't say mutual agreement, but everyone in the stakeholder is agree. So stakeholder, I already mentioned, stakeholder is people or people who involved in our system. For example, in our staff student internet, stakeholder is the student, the TARUC, the provider. It's not provider. It's not developer team. Yeah, developer team, testing team, those who are involved. That one is stakeholder. So agreeing objective, that's mean everyone in this stakeholder already involved, already agree with them. And planning test. So planning test, in OOAD, we rarely talk about test. However, we have this one, we have a cost for this one actually for testing. Quality, I forgot already the name. But planning test is very important because in planning test, we have a document where we call as a test case. Test case? I think it's like test case. But when we testing our program or module, we need to follow that test. So even in test, we need to plan ahead. We need to plan before the system is completely developed. Okay, it's like planning test. So we have to put just one document. I forgot already what the name. And then agree procedure to decide on trade-off that significantly affect the system. Okay, trade-off here in this chapter, we will look better and planning time for different aspect of design. Okay, we need to, this is all for planning, but here for design, different aspect of design. And then development standard. We have this HCI, Human Computer Interaction Guideline, Input and Output Device Guideline, Construction Guidelines. Okay, this guideline is like I mentioned just now, it's like it's not a rules, but it's like a standard that we need to follow. Yeah, of course it's standard. So it's like a standard that we need to follow. Okay, for some serious business, for example, if you go to website Apple, yeah. If you go to website Apple, if you see, because I'm actually for my study, actually for PhD, I'm focusing on UI, UX, and HCI stuff. So I am very I'm not, how do you say, because I'm focusing on this area. So like I know which one or which user interface have a good interaction with the user. So if you go to, for example, if you go to Apple website, if you compare, if you see that their website, actually I think they have a good group. Of course it's Apple. I think they have a good group of designer, because actually for one button, actually to place them, for example, if that button back button should be, I want to ask you guys, if you want to design a back button, where do you think it should be, uh where do you think that you should put, or you should allocate that button? For back button is usually on which side in your interface? I want to ask you guys. Bottom left side. Yeah, usually for back, usually we have two. Usually, for example, we have, for example, I have for example, we have two button, which is back or previous page or next. So usually for a good UI, that button should be placed on the bottom one, bottom left. If we have two button, we should be button left here, or on the top left here. It should be on the left side. Yeah, left. It should be left. That's mean that one is related to what we call, as I mentioned, UX, user experience. Because user experience, for example, we as a user, usually we know that this button should go here. For some system, for some system or website, usually they don't have this what we call as navigation. In our interface, we have this term navigation. That's mean user already have that experience even before they go to your website, even before they use your system. Okay, so we need to apply that UI and UX, what we call as navigation. So this button should navigate here, so they should know when they click this one, it will bring them to the previous page or previous slide maybe. So that one is considered as SI. That's why sometimes when I see website, or sometimes when I see, yeah, some system or website, I have this, like, I will ask who designed. Usually I just ask, not really serious. But yeah, HCI guideline, the standard they need to follow. IO device guideline, okay, and construction guideline. So this one is IO hierarchy, providing consistency for device handling. So this one, as you can see, we have three class. Yeah, IO device, sensor, and actuator. Actuator, actually I already Google this one. This one is actually a device to convert something to something. I'm not sure what device is this. You can go and Google. However, this one is like a convert. But the point here is in the class. We have three class here. So this one is referring to IO hierarchy. Okay, IO device, we can have the sensor and actuator for the for device handling. Okay, so this one is the development standard. We can see this two is under this IO device, sensor and actuator for handle event. Okay, this one is the trade-off I mentioned. So designer is often faced with, oh, designer here, since I mentioned UI UX this now. If you want to be a designer, designer is a job, is one of the job in our field. So designer usually they will designer, they will usually they will involve with, of course, the name designer. So they will involve with UI UX stuff and things. Okay. So designer is often faced with design objectives that are mutually incompatible. What is it mean by mutually compatible? Okay, remember I mentioned in this class, I said for business perspective, usually the BA will set yes, we can do, yes, 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 and yes, we can do everything. But sometimes, just now I mentioned about the programmer. When the BA said this client want this one, want this specific requirement, we as a developer think that, oh, that is not doable. We cannot do that because of this, and this. So here in this context, designer and the objective are often faced with mutually incompatible. Sometimes what the client want is not something, I won't say that it's not something that they cannot design, but it is usually mutually incompatible. Okay, it is, yeah, mutually incompatible between the design and the objective. So that is a challenge for a designer. Okay, it is helpful if guidelines are prepared for prioritizing design objective. Okay, so to avoid this situation mutually incompatible with the objective, so it is very helpful if the guidelines are prepared to check the objective, is it compatible with the design or not. Okay, and if design choice is unclear, user should be consulted. Yeah, design should be consulted. That's mean you just confirm back with the user if this is this what you really wanted, because if we want this, for example, they want to the for example, if they request for one function, but then the user interface, or I mean the design of the patch is not compatible, they should confirm back. Actually, for a designer, when they already design, they will show them if this is what you want, this should be the interface. They come with a prepared interface like what the client requests. So they need to confirm back, is this what you really want? So if this is confirmed, then this one should be the design. Okay, so design to meet all these qualities may produce conflict. Like the same in the previous slide. So conflict again with the conflict between the design and the objective. Okay, sometimes our user, our client, they do not know, they don't have that experience in the UI UX. So you as a designer, you should know, you need to know what is doable or manageable or not. It's not manageable. What's the term in the element just now? There's 12 item. Doable is not in there, but there's one term that I said, usually we say it as doable. So you need to know if it is doable or not. Okay, so trade-off have to be applied to resolve this. Okay, to solve this issue. So functionality, reliability, and security are likely to conflict with economy. So I mentioned already in previous slide. I don't remember which slide. So sometimes the user, they request to have this functionality, this, and that, and then they want to have high security, but the budget is very low. So always they have conflict. They have this, for example, for a system, maybe they want to, for a system, for example, uh, 1 million for banking is too small. But for example, our system, 1 million, they only capable, or they only affordable to pay 1 million, but they want this function and this function and this function. Of course, that is cannot be done, because of course we need to shut some of the function based on their budget 1 million. That's not enough. Of course, always have conflict with this thing, functionality, reliability, and security. And then level of reliability, for example, is constrained by the budget available for the development of the system. Like I mentioned seconds ago. Okay, we have this budget constraint. So reliability, for example, usually it's not on reliability. Usually it will go to functionality. Okay, every function that we give to our client or we deliver to our user student, they need to have the reliability. Okay, reliability, for example, just now I mentioned reliability is the level of our system, the tolerance level of our system when they have something like software or hardware failure. Okay, that one is reliability. We need to have that function. However, budget usually referring to this function. They want function, many function, but they have limit budget. So prioritizing design trade-off. So design objective may conflict with the constraint imposed by the requirement. Okay, so the requirement that the system can be used in different countries by speakers of different language will mean that designer have to agree a list of prompt, label, and message and refer to this by some system and name or numbering. Okay, this requirement of the system. For example, like I mentioned, for our user, for our system, we deliver our system into few countries. For example, if we deliver into Bank A in Malaysia, for some country, they are using their native language. For example, I'm not sure if Hong Kong, if I'm not mistaken, our client, I don't understand the system, but they are using totally different language from us. I know the system, but I do not know the language, the button, everything that they use. I don't understand. So here, here as a designer, you need to have a agree list. For example, anything that related prompt message or any requirement for some naming and numbering. Okay, this one is also referring to the point in or to the element which is flexible just now from the 12 element. So we should deliver our system into different environment. Here is in different language. Okay, so this increase flexibility and maintainability, but increase cost of design. Yes, correct. Why? Like I said, increase flexibility. One system we deliver into few countries and maintainability. Okay, and but increase the cost of design. Usually, this one is actually a business. I don't know, business. What the term? Business play, business game. Actually, for example, we have that system already, but the issue is only changing the button name. For example, back. So we just change them into the language. I don't know what the people they use the language. So it's only like business game. The function is already there. We just need to change the design. So because I involved in programming, I involved as a programmer last time. So I know that thing is only changed on the front end language. We doesn't need to touch at the back end, but of course, like I said, it's a business game. It's actually easy to actually very, I won't say very easy. It's actually easy to change, but yeah, of course, there will cost of design and design for implementation. So initialization and implementation issue should be considered. Okay, how they want to implement. So there may be data transfer and or data conversion requirement. This one is for implementation. So summary, in this lecture, you already know what is the difference between analysis and design, logical and physical, system and detail system, good design, and trade-off design just now. So in this lecture 2, you have, I think, 1, 2, 3. Yeah, 1, 2, 3 exercise. Okay, so for exercise, we will discuss together with the, I think, chapter 8, if I'm not mistaken. Let me check this. I think we have exercised one more chapter that we haven't discussed. So for this one, we will discuss in our tutorial this week. Start already. We will discuss this in our tutorial this week. Okay, so please do this one. For this one, I won't give you time to do in class. I expect you guys to finish this one before our class, so we will discuss. Okay. So I think that's all for our class today. So here we already done chapter week 12, which is on uh system design. So next week we will proceed with uh system design detail design. System design detail design. Okay. So for this one, how many designer per project usually? Usually it depends on the size of the project. Okay. Depends on the project. For some system, I think for user, for for your system, student intranet and staff intranet, I think they have a thing. No, No, usually designer, like programmer too, we have a team. So this person do this model. So some with designer. So for example, one person will assign to one module. Depends on the size. Yeah. Usually designer have less stress compared to programmer. I'm not sure because I'm a programmer, so I have bias on that. Okay, so before we dismiss any more question, Noel, do you have question? If you want to be a designer, you should master this thing, UI, UX, HCI. Yeah. So, oh, for example, let me give you one example before we end this lecture today. For example, I mentioned you guys, right? For my master, I developed one application, gaming application. It's not gaming, learning application, which include the gamification element. So gamification element, we have many gamification element, but I need to know which element is needed for the learning application. So that is another concern in designing. That is one example actually. So yeah, since no question, I assume no question, we can dismiss now. Okay, see you on Wednesday. Thank you, student.